So we'll look at this table, and you'll notice I kind of picked some weird points for graphing this, not just our typical 0 to 2 pi like we were doing with sine and cosine, and we'll see why in a minute. So tangent of negative pi. If you think about the unit circle, this is pi, right? Pi over. Okay, negative pi just means you spin backwards, so it's the same as positive pi. Okay, this point on the unit circle is -1, 0. What's the definition of tangent?
Y over x.
So, what do we get for negative pi? 0 divided by -1 is 0. Okay, -3 pi over 4. So if you're thinking about the unit circle, it's in quadrant 3. Tangent is positive in quadrant 3. Reference angle is 45. Tangent of 45 is radical 2 over radical 2, which is 1. Negative pi over 2 is right here. That's the point, 0, -1. Y over x, -1 over 0 is, okay, negative pi over 4. So that's in quadrant 4. Tangent's a negative in quadrant 4. Tangent of 45 is 1. At 0. This is the point 1, 0. Y over x, 0 divided by 1 is 0. Quadrant 1, tangent is positive. Tangent of 45 is 1. Pi over 2. This is the point 0, 1. Undefined. 3 pi over 4. -1, and pi, we're back here, 0 divided by -1 is 0. Alright, so these are going to represent and halfway in between them would be the other points here. And pi over 4s. This is 1 and -1. So tangent of negative pi, we got 0. -3 pi over 4, it was positive 1. Pi over negative pi over 2 is undefined. That's a vertical asymptote. Okay. At negative pi over 4, we had -1. At 0, it was 0. At pi over 4, it was 1. Pi over 2 was undefined. 3 pi over 4, it's -1. And pi is back to 0. Alright. So if we think about this, we know from algebra that asymptotes we're getting closer and closer to the never touching, right? So this would have to be approaching, getting close to, but not touching. Just like our others, we could put in more points and see this for sure, but these are curves. It's not lines, just straight lines. Alright, so tangent has asymptotes in it. How many periods did I actually graph right here? I think we had positive part, we had the negative part, and then what happened? Yeah, so really, just from graphing from negative pi to positive pi, we had 2 complete cycles of this graph, right? In terms of graphing, if I said to graph 1 period, you could graph any period you so chose, but it's usually a little bit nicer if we can have one solid section. So typically, when we graph tangent, we will use the interval -pi over 2 to positive pi over 2. Because in that section, we get one complete cycle of tangent, we have asymptotes at the end, and we can figure out what it looks like from there. Okay? So it's a little bit different than sine and cosine in that its period is shorter. So this one I put 0 to 2 pi on here. Think about your unit circle. Cotangent is x over y. So cotangent of 0 and pi. Pi over 4 is 45 degrees, so it would be 1. Pi over 2, y over, or x over y, 0 over 1 is 3 pi over 4, -1. At pi, 5 pi over 4, 3 pi over 2,
0.
1, and 2 pi, we're back to, let's figure out what this is. So cotangent of 0 was undefined. Pi over 4, it was 1. Pi was 0. 3 pi over 4 was -1. Pi is undefined. 5 pi over 4 is 1. 3 pi over 2 is 0. 7 pi over 4 is -1. And 2 pi is undefined. So just like tangent, this is a curve approaching your asymptotes. How many periods? I just graphed 2 periods, didn't I? So if I were trying to pick 1 period, and I see 1 complete cycle, the easiest option would be right here, 0 to pi. Tangent and cotangent look very, very similar. The difference is tangent is increasing and cotangent's decreasing. And the intervals are weird. With tangent, we are going to choose -pi over 2 to +pi over 2. And with cotangent, we're going to choose 0 to pi. Last thing for today. Let's just kind of jot down. So you can put this in your notes or on this handout, whatever you want. So the interval we like for tangent is going to be -pi over 2 to +pi over 2. And again, that is only because that gives us one nice complete section. The normal period for tangent, the length of time until it repeats, is just pi. The distance from -pi over 2 to +pi over 2 is just a total of pi. Is tangent even or odd? Talk about that with sine and cosine. Even meant symmetric with the y-axis, odd meant symmetric with the origin. Takes 2 flips. So tangent is an odd function, which means if we have a negative on our x, we can pull it out in front. With cotangent, what interval do we want to use?
0.
The period, what's the distance from 0 to pi? Just a 1 pi. So both of these have a normal period of pi instead of the 2 pi that we saw with sine and cosine. Alright, is this even or odd? So we know if we continued our graph in the negative direction, it's just going to keep repeating. So is this thing symmetric to the y-axis? If I fold it over the y, does it overlap exactly? No. Cotangent is also an odd function. So that means if you have a negative on your x, you pull it out in front. So far, all of our functions have been odd with the exception of cosine. So with all of them, if we have a negative, we pull it out in front, with the exception of cosine when we can just drop it. Is this okay? So we will actually pick up with more on graphing these tomorrow.